Right, so I'm talking about three big ideas. The first one being drawing the graphs of inverse sine, inverse cosine, and inverse tangent. So let's start with something like this: y equals sine of x. So we've drawn this graph several times in the past. And we said on Friday that the tangent graph, that the sine graph really matters from negative pi over 2 to pi over 2 when we're talking about domain restrictions. So we said what? The domain would be negative pi over 2 to pi over 2. We said the range, if you think about this segment, the range is negative 1 to positive 1. Right? So, the question is, how do we draw the graph of this? Well, at a minimum, I know the domain of this must be the range of the original because the x and y values just switch. So this used to be the range, now it must be the domain. This used to be the domain, now it must be the range. So now let's draw the picture. And I think the easiest way for me to draw the picture is to say, well, let's pick some points on the original graph, switch the x and y values, and then plot those points down here. So this point right here is pi over 2 comma 1. That means the inverse graph must have a point 1 comma pi over 2. Let's put that on. 1 pi over 2. The original graph has a point 0, 0. When you switch 0, 0, you still have 0, 0. And finally, the original graph has a point negative pi over 2, negative 1. Negative pi over 2, negative 1. This graph must have negative 1, negative pi over 2. And you have some sort of S-shaped curve. It's not a straight line. Really, if you can just get the domain restrictions and understand where these points come from, the connecting of the dots isn't too crucial. Questions? Cool. Let's do the exact same analysis for cosine. So those who are with me can draw the cosine graph on their little space they have. I'll unfreeze in 1 second. I just want to give people a chance to. So you draw the cosine graph, identify the domain restriction and the range. So the domain restriction we said was 0 to pi this time. The range of the little yellow part here, of the segment, if you will, is negative 1 to 1. Understand, the domain and range will switch now when we do arc cosine, also known as inverse cosine of x. So the domain of arc cosine is the range of the old one, so -1 to 1. The range of arc cosine is the domain of the old one. And let's plot some points now. So again, I'm going to plot the points just like I did for sine. Some of you are already doing that on your own. That's great. So the key step is identify some of the easy points on cosine. Okay. And now just flip them and plot them on the arc. I'll do that. Let me know if you have questions. And again, some kind of S-shaped thing here. Again, we don't really care about exactly how you connect the dots. We care about that you understand where the dots are and what this domain and range is. Let me stop here and take questions before I do the exact same thing for tangent. Those who are good can draw the graph of tangent on their page. I'll unfreeze in 1 second. And then write the domain restriction and the range for tangent. So here's what we're thinking about with the tangent graph. Again, there are many more branches. I'm going to stop because we only care about one specific branch. Please note the domain for tangent has parentheses. Understand why. If you don't, now's a great time to ask. Please note the range for tangent is all real numbers. Please understand why. Now, we're drawing arctan, namely inverse tan. Understand what happens to domain and range. Things are not clear, please ask. Very interesting things happen to the graph here. I would encourage you to first deal with these asymptotes. They used to be vertical. Now when they switch, a vertical asymptote must become horizontal. So horizontal asymptote here at y equals pi over 2. Horizontal asymptote way downstairs at y equals negative pi over 2. The original tangent graph has the point 0, 0. This must have the point 0, 0. Connect the dots. The graph is approaching the horizontal asymptotes, but not touching. Questions? All right, that was the first skill we wanted to build. Part 2 of today is on the winter break homework. Page 2, round 2, this problem with the box. Any questions on where we are? Page 2, round 2, box, right here. All right. These are those angle rotations that we did before in the good old days of 4 weeks ago. We're going to revisit them. So it says, imagine theta as an angle in quadrant 1. All right. Angle, quadrant 1. And they're telling me that the cosine of the angle is A, sine of the angle is B. And then they're asking me several questions based on rotating this angle. Sine of negative theta, cosine of negative theta. Let's start with those two. Think back to your rules. We learned specific rules for both of these in Unit 5. I'll write the rule that we learned, and then you can try to apply the rule to get the answer. We called sine an odd function. I hope this is the answer you get for sine. We called, and again, if there are questions on these two, I'll be happy to take them. Let me just get these down. This is what we talked about for cosine. And I hope you're getting this. Those who are good should probably keep going. Those who have questions, please ask. Okay, number 3. I'll write another rule. We said I'll also draw in where angle 3 is. Remember how we talked about coming here? So here's number 3. Number 4, again, please stop me with questions. I don't want to say too much with these problems. I think many of you all are already able to do them. But obviously, if the logic does not make sense that I'm writing, please let me know. This one, I'll give you all the first hint for number 4 is to rewrite this as we always talked about. Here's the answer. Let me stop here for 1 through 4. Again, if you're good, please keep on going. If you have questions, now's a great time to ask. So those who are good, keep trying number 5, which brings in a little bit of a tangent. Are there any questions on 1 through 4? Okay, so on number 5, remember anytime you add or subtract 2 pi, nothing changes. You get back to the same spot. We talked about when you add 360 degrees. So this is really just another way of writing this. Remember from last Friday how you can write tangent using sine or cosine, rather sine and cosine. And then fill in the blanks.